Hi, everybody. My name is Eric, and I work for Fireblocks. And in this conference, I think quite a few of you heard about us. So basically, we do an MPC wallet infrastructure to allow organizations to work with the blockchain, right? Like to provide different services. We serve quite a lot of people. Actually, the numbers here are not good. They're up quite meaningfully. But there were multiple trillions of dollars. I think the last public number is 6 trillion already that have passed through Fireblocks. A lot of wallets created, a lot of customers. So this is an MPC system that's not like a idea of an MPC system. It's a production with a lot of money going through that. And so as we build this up, we learned a lot about what it means to actually build a secure MPC system, right? So let's talk about this, and I'm not going to do an intro to MPC, just like a very slight, make sure that everybody is on the same page. So MPC is generic, right? There's a lot of things you can compute with MPC. When we talk about MPC in the blockchain world, most of the times we will be talking about threshold signatures. And the way it will be used is we have the key, and we don't want to have a single key, which is a single point of failure. We want to have multiple keys or multiple shares of a key in our situation. And whenever we want to compute, like this compute inside the MPC, we want to compute a signature, we will do it in an interactive protocol between all of the parties that hold the key. Now, since we're dealing with a private key, and before that, I told you that we have trillions of dollars passing through our system. Security is really important, okay? Like, really important. And so we constantly ask ourselves, how do we make this thing secure? Luckily, it is solved because it's actually called secure MPC, okay? So the cryptographers solved it already. It's secure MPC. But just for us to understand, what does secure MPC mean in this context? Secure MPC means that this is an MPC protocol, right? The MPC by itself did not assume that like the parties will act in a way that assures security. But in the secure MPC protocol, the parties do not trust each other. Okay, so each party will act as if the other parties are malicious. So it will not necessarily trust their computation. It will ask for assurances, right? There's multiple different protocols that implement secure MPC, all the way from the GGs and Lindell and CMP and DKLS. And there's like a lot of different options for implementing secure MPC. And eventually, there's this trust aspect. You do not trust other parties in the protocol. And then there's the security kind of like guarantees, right? You test for the security within a specific, what kind of attackers do we assume that are going to be, what kind of capabilities they have. You do the entire security analysis. So you can say, within these security assumptions, this protocol is secure. So that's the way that a secure MPC protocol gets us to. And so what you would expect is that the first thing everybody would do is implement a secure multi-party computation protocol well. So what we found when we did some security research, because we do a lot of security research on MPC, is that a lot of parties, a lot of companies do not get to that way, where they implement a full MPC protocol as defined in a secure way. And this is just a small example. We're not going to go into all of the vulnerabilities. If you want to watch that, you can look at the Black Hat DEF CON videos that are out there. We presented this last year. So what we saw, for example, this is an excerpt from the DG18 protocol. So we saw a company that implemented all of the green parts, which is the honest but curious implementation of the protocol, but didn't implement the yellow and red ones, which is the security layer. So it was an MPC protocol just without the S at the beginning. So obviously, this is hackable. Actually, with some creative mathematics by our cryptography team, it's hackable in the first round of the first transaction. You can basically extract the entire key. Again, there's some fancy tricks in there. You can read about it. There's a paper that covers all of the different things that were done there. So obviously, you don't want to do this, right? You don't want to do an honest but curious protocol in a real MPC system. So that's one thing. But it gets a bit more complicated because in the same presentation, we presented another thing, which is a vulnerability in the usage of the Lindell MPC. Now, I was careful with my words here, okay? Why? Because the actual protocol is fine. The actual protocol works as expected, and it has this line that basically says that as long that this implies security, right? This protocol is secure as long as you abort, if there's a failure, you abort any additional signatures, right? That's the definition of the protocol. If you take this assumption, you build the protocol, it's secure, everything works as you expect. The problem is we did not find a single implementation that does this, that aborts after you have a failure, right? And if you don't abort when you have a failure, then you expose a bit. And then the next time, you expose another bit. And then you can do the math. After a few times, you get the full key, right? And so this is something we saw in, again, like the companies we saw that use Lindell. And what this shows is that you can do a good job implementing the MPC. You can do a good job implementing the system around the MPC, but they don't necessarily connect as you would expect, because the security assumptions that the MPC protocol has versus the security assumptions that you might have in your system or even in your product. Because, like, just think about this for a second. You have a crypto wallet, and there was a failure, but you have money in there. It might be a lot of money, but now we tell you cannot sign anymore. That's like there's a problem here, right? Like the money's locked. That's not a good product. It's not a good product, so nobody built it that way, right? So like, so there's like an inherent tension sometimes between the security assumptions of your secure MPC versus the product you want to give to your clients. And I think especially like when this is done in one company, this is hard. Like to make sure that you have proper communication and understanding. And there's a lot of implications, like which site starts and other things. So it's hard if you have it in the same company. But if you actually use an external vendor that kind of gives you an MPC in a box, which there's a lot of vendors that are doing this today. So like, what is the chance your team actually understands how to use that MPC in a box you got, and you will not get some improper implementation of security assumptions once you do that? So that's obviously, like, as far as I'm concerned, I think this is something that's really important to notice. So, like, just to cover this part, what do you need to do, right? You need to make sure you choose an MPC protocol that's good. There's multiple MPC protocols that have not been broken. There's some old protocols we already know they're not good enough, right? Sometimes in their paper, they actually says they're deprecated. It doesn't stop people from using them. So you need to implement it well. And then you need to make sure you implement the system around them in a way that actually understands all of the nuances of this protocol, including the quirks, including the small things, because that's what hackers look for, right? The quirks. And then you need to audit and make sure it tests and everything. And the last thing that we noticed doing those experiments, we were very, very careful in our security research, did like the disclosure process with over 20 different companies that were vulnerable in this or another way. But when we were testing, we were sure that very quickly, as soon as we have one bad test, somebody will block us. Because they'll understand we're trying to do something that's not as it should be, but nobody in any of the companies we tested this on, again, in a very careful way, ever noticed we're doing it. So you should have monitoring as well, right? And again, when we build, like cryptographers write their MPC protocol, usually they don't talk about the monitoring part of it. So like you kind of need to make this connection with the security researchers. Okay. So this is good. I think we have a simple approach towards secure MPC. The only thing we didn't account for is the big enemy of secure MPC protocols, which is the IT guy. Now, the IT guy slash DevOps slash admin slash the CTO that still has access to all of the system, even though he really shouldn't at this point. This is really risky, right? Because MPC just assumes a lot of things. Like when you write the cryptography, you write the protocol, you assume a lot of things. For example, you assume that the parties are actually separate. And IT people have access to a lot of systems. So you might have one person that has access to all of the computers that run all of your very decentralized, distributed, protected MPC protocols. He can just change it all. So let's talk a bit about, and obviously, when I say it's not just the IT person, right? Like, they're all good and nice people, and we love them. But the hacker who got access to their account and now works with their permissions, he's a real problem. OK, so here comes the magic of secure enclaves, trusted execution environments, and there's a few more names for it, right? SGX and Nitro, like, everybody has their flavor. So this is kind of like the template, right? Everybody who does MPC today, it's like MPC plus TEE. It's on the marketing of a lot of websites. And so obviously, as a company, this is our bread and butter. We sometimes look and try to understand what it is that people would do. What does it mean to have trusted execution environment and MPC connected, right? So the most simple thing you would think about is this. Let's just put the key in the trusted execution environment, right? So that's kind of like a KMS solution, sort of, right? But then you understand it's a bit more complicated because the secure enclave does not necessarily know how to do all of the actions you want them to do because MPC just not ask for simple signing, right? In the MPC protocol, you need a bit more complex signing. So you have like the code. You have the MPC code. And the MPC code has all of the nuances, but in the simple implementation I just put out there, it's outside of the enclave. So that may be OK, but we have that IT person, right? And he can access anything that's outside of the enclave. So by the way, just kind of like to set the ground when we talk about secure enclaves, the idea is that this is the part of the machine that even the operating system should not have access to, right? So it's basically, it can run on the CPU and it connects to the secure encrypted memory without the operating system having the ability to see or change or do anything within this. It's like part of the hardware, and there's attestations that you get for how it works. I'm not even going to go into the differences because different TEs work differently, and if you build the same code for all of them, and you're not an expert, you're likely to make some mistakes. But we're not going to go deeper into TEs in this. OK, so we have the MPC code. It's outside. It's not good, right? Because I, as an admin on the computer, I can come to the code that you have in the MPC, change it. Instead of signing, I ask you to sign, plus do something else, right? Or change the signature. Like, I can do a lot of things. I can probably expose the private key because I have access to the KMS. I can just ask for the key, whatever. Depends on what it allows me as an API. So that's not good. So let's put the MPC inside the TE as well, right? That's easy. And now it's solved. Now we have secure MPC inside the TE, so I cannot change the code of the MPC. And if the MPC is good, like we said in the first part of this session, we're done. But now I want to introduce you to a really cool story. So there was a guy, and he had an open source, not MPC related. The open source was called LeftPad. And LeftPad did a very small thing. It would pad on the left. This is the entire code, OK? This is everything. That's all the code. Now, the thing is, people love using open source in their software, so this code was used by everybody, OK? So pretty much every system in the world, somewhere down the line, somebody was calling LeftPad, NPM package. And this guy got pissed on another company. They annoyed, like there was like a legal thing there, and he decided to take it out from NPM. And so the internet literally crashed. Like so many systems that were trying to deploy and didn't have proper protections from deploying code that's no longer on NPM, broke, couldn't deploy. There was a lot of chaos. Why do I tell you about this story? Because it really connects to possibly my favorite XKCD. Which is eventually all of the software depends on some open source project maintained by a guy in Nebraska that does this for his fun. And if it's not fun anymore, he might not do it anymore, like the LeftPad guy, right? But how does this relate to MPC? So you now took your entire MPC code and put it in the secure enclave. And what I claim is maybe your MPC code has a LeftPad library in it. I'm not saying it does. But maybe there's some open source libraries in your MPC code. We can probably check. So I look at the most popular MPC library by the BNB chain, like I'm assuming a lot of people that used MPC at some point worked with it. So these are their dependencies, okay? Like that's like just the latest. So there's obviously a few things here that are internal, but there's a few things that are not. For example, there's this library. Now, this library is deprecated. Now, I do want to give to their credit. If you look at the bottom line, they solved it, okay? They replaced this library. But just FYI, they had this library that's deprecated and actually said, we will not fix the security issue we have in our system, okay? So that's in there. Again, we need to give them credit because they did replace the dependency at some point. I didn't check when. But there is also this library, which is basically some blockchain's implementation for an elliptic curve. That library is not like a one guy like the first one. It's more like hundreds of people that deploy to that library. Like there's a lot of people that work on that library. Now, I'm not sure which one is good or bad, right? In one, it's like one guy. In the other one, it's a lot of people. The question I want to ask is, when this update of dependencies happened, what is the likelihood that they audited all of the code changes in every dependency library that they had in their protocol and they know exactly what's going in there, right? What is the likelihood that somebody upgrading this, using this library from V200 to V201, that the person using started auditing all of the changes that were in that library, right? I don't think it's a very high chance that that happened. And that brings us to supply chain attacks. So MPC protocols that have these kind of dependencies, and I'm not speaking on this library specifically, are definitely susceptible to supply chain attacks. Now, if you manage a lot of money in your MPC protocol, somebody might want to slip in a few lines of code into your MPC. And if it does, then that line of code is now in your MPC code inside the trusted execution environment. So it's nice that we protect people from the outside, but we might actually bring the enemy inside, right? And then inside the TE, they can do whatever they want, whatever code they put in there. Supply chain attacks are becoming a big deal in the general ecosystem for developers. We've already seen a few of them go pretty wild. And I think it's definitely possible that we'll see them in the blockchain space as well. And then we want to talk about the deployment of this code, right? We talked about how this code gets into the system. The question is, who deploys, right? Until now, we said we have code in a secure environment. Inside the TE, you cannot change it. But somebody does, right? Somebody is changing the code, making upgrades, possibly. So what we see today is there's a lot of different ways that people want to structure their MPC architecture, right? Like we believe that part of the MPC shares has to sit with the clients. Not everybody believes that it needs to do that. But then the question is, who's deploying the code? Because you might not be able to deploy code to your client's machine because they have control. But if you have 3 machines and you have MPC on them, what stops you from deploying different code into the TE, then verify that the code you deployed is malicious, is actually in the machine, and then run it, and then, you know, again, a hacker. I'm not talking about the person actually building the protocol. So this setup. Now, the problem is, why don't people love putting the share on the client side? Because it's harder, right? Like, suddenly you need to deploy code that in a place where you don't support, so you need their agreement. They might question things, and there's more latency, right? Suddenly you need to handle, like, some of the protocols in MPC that are really fast on computer, but not so great on the network. So there's a lot of complexities once you care about this. And again, as we said, MPC is hard as long as you don't care about security. So deployment is important. That's like an area that's really important. But it's not the only one, right? Because let's say I have my secure MPC, but then who promises that the transaction I sign is actually secure itself, right? So we solved the MPC part, the signing. Let's say we solved all of the problems. The signing is secure, but secure signing does not equal a secure wallet. Because then what if I bring a malicious transaction and you sign it properly, like within the MPC? The MPC doesn't know what the transaction do. So we know that a lot of companies, MPC wallets and others, have policies. But then your policy is outside of the TE. So now I can change that code, right? So let's bring the policy inside the MPC. But then we just go one step further. What's right before the policy? Serialization Is that inside the TE? What if I put that in the TE? What's before the serialization? You kind of understand where this is going, right? Like, we can keep pushing the problem, but eventually all of this, and so some of the secure implementations do put all of this code. But when you read on a website, TE plus MPC, they don't tell you if your policy is inside the TE or outside. It's much easier to put it outside of the TE because like it's easier, you know. So there's a lot of things you don't need to solve. So yeah, so this is again, it's solvable, but it's hard. You need to start layering a lot of security layers on your protocol to make secure MPC actually secure. So what do? Right? So the first thing, as I mentioned, is security in depth. There's no single silver bullet that solves everything. You need to have many, many layers of security to make your MPC protocol actually secure. It starts with a secure MPC implementation, continues with understanding all of the nuances, continuing with expertise in MPC to also identify new vulnerabilities, new issues that come up, continue with understanding trusted execution environments, understanding how to work with them, understanding their nuances, what's actually inside the environment, what's outside the environment, how that works. Making sure you understand your dependencies, making sure you control your dependencies, that you know how to bring in improvements without adding risk every time you improve, because if you did the audit on the last version, you upgraded dependencies, that's like entirely different code base. There's a lot of issues when you start to work against real adversaries versus when you go against the naively defined hackers, right? Like the ones that will only work within the constraints of your algorithm. So that's why it's actually quite hard to do TE plus MPC together in a secure way. So MPC is easy, unless if you care about security. Thank you.